Hello, welcome everyone and welcome back to my channel. As you know, we were doing simultaneous equations. We have already completed linear simultaneous equations, worksheet on it, and even the worksheet on the worded problems. Today we are starting non-linear simultaneous equations. Try to understand this, why it's called non-linear simultaneous equations, because either one of them or both can be a non-linear equation. Like take the example of this one written here, that's here. So this one is, you can clearly see one is linear and another is non-linear. If both will become linear, in that case what will happen? That's called linear simultaneous equation. But if one or both are non-linear, it's called non-linear simultaneous equations. Obviously, if it's a non-linear simultaneous equation, the graphical interpretation of would be a curve. That's what here. That in your syllabus, generally either the equation is a quadratic equation or a circle equation, and they will give you any one of them. So that's the most common that you will find. But in any other cases, it can be a cubic equation, it can be any sort of equation. And when you plot it, I was talking about the graphical interpretation, so when you plot it on it, you will get a curve. That means they are actually talking about the intersection of the curve and a straight line. So this is a curve, and like this one, and this is a straight line. So we are finding the common intersection point of these two curves basically. So let me see the rest of the part, that how to solve this, because obviously this is the basic knowledge of graphical interpretation that I told you. But obviously we will be seeing like the next video will be on properly on the graphical interpretation of the linear equations and non-linear equations, and like when both are linears, both are non-linears, one is linear, one is non-linear. So that I'll be explaining you in a whole different section. This is the basic one that you have to understand, that there is a curve, there's a straight line, and simultaneous equations, that means when they both are sharing the same values of the variables. That means graphically where they are intersecting, because that's the only point where they both have the same common points. This section is all about solving them algebraically. So that's done by substitution method. Substitution method is all about substituting value of one variable into another. That means take an example of this one. Let's say this is our equation. I'm explaining you here. Our first equation is x plus y is equals to 8. So x plus y is equals to 8. And our second equation is 2x squared plus y squared is equals to 43. Now obviously if you go for elimination method, it won't work, so you have to do substitution method. That means you have to substitute one variable into another. So these are our two equations, and now the substitution thing says, and I always suggest you that always you have to start from your linear equation. Don't start with your non-linear equation. That will become so much difficult, right? If it's just 2x plus y squared is equals to 43, then it would be fine. But in other case, when both the variables has power, or you can say one is a quadratic equation, so in that case it's difficult. So better is be safe and always start from the linear part. So from here, x plus y is equals to 8. I can start any one. I can just make the subject any variable. Let's say y is equals to 8 minus x. That's my first equation, and this is my second equation. I have to substitute this value here in the second equation. That's called substitution. You are basically substituting the values from one equation to another equation. So that will give me 2x squared, and in place of y I'll use 8 minus x whole squared is equals to 43. Then this will be 2x squared plus 64 minus 16x plus x squared is equals to 43. X squared will be 3x squared minus 16x, and bring it here, and this will give me plus 21 is equals to 0. we have to solve this quadratic equation, and we have to see the product should be equals to 63 and sum should be minus 16. So in that case, it's simple. We can pick 9 and 7. So 9 and 7 will give me 63, and at the same time they will give me the sum as 16, but both have to be negative because product of two negative number is positive, so obviously we need positive 63, but our sum is minus 16, so that will be 9 and 7. So that can be written as 3x squared minus 9x minus 7x plus 21 is equals to 0. Now we have to make pairs, and from the first one I can take out 3x as common, remaining is x minus 3, and from here I can take out minus 7 as common, so it's x minus 3 equals 0. Now in brackets we have 3x minus 7 times x minus 3 equals 0. So we have these two values. X1 is equals to 3 from here, and from second I can say x2 is 7 over 3. Once we have these values, we can substitute in either of the equation. Best is to start with to substitute in the linear equation. It's much more simpler. So y is equals to 8 minus x, that means 8 minus 3, which will give me 5, that's y1. And y2 is 8 minus 7 over 3, that is 24 minus 7, that will give me 17 over 3. And that we got here as well. Y1 is 17 over 3 and y2 is 5. And similarly, x1 is 3 and x2 is 7 over 3. That's why. So in this way, we can solve any question. Let me see one more question. Here is the example. 2x plus y is equals to 4. So your first equation is 2x plus y is equals to 4. And second is 7x squared plus 5y squared is equals to 27. As I told you that you have to start with the linear part. So I'm starting with linear, and making y the subject is much more easier. Only just bring 2x onto the right hand side. So y is equals to 4 minus 2x. Now this one, let's say this be equation 3. I have just rearranged the first equation. That's all I did. I need to substitute this value of y here in the second equation. So that will give me 7x squared plus 5 times 4 minus 2x whole squared is equals to 27. Now expand this. Most common mistake I have explained, or I have discussed this earlier as well many times. Don't do 4 minus 2x as 4 squared plus or minus 2x squared like this, and you get your answer. No, it doesn't work like that. 4 minus 2x whole squared, that means 4 minus 2x times 4 minus 2x. This is double bracket and you have to expand it to get the answer. So that will give me 7x squared plus 5 times 16 plus 4x squared minus 16x is equals to 27. Then 7x squared plus 80 plus 20x squared minus 80x, and bring 27 onto the left hand side, so minus 27 equals 0. That will finally give me 27x squared minus 80x. So that will be minus 80x minus 80x, and 80 minus 27 is 53, so plus 53 equals 0. Now I can't take anything out as common in this case, so this can be done by the simple quadratic factorization method. The product should be 27 times 53 and sum is minus 80, so we can clearly see these two numbers are there right in front of our eyes. That means minus 27 and minus 53 itself. So 27x squared minus 27x minus 53x plus 53 equals 0. You can use the formula as well, the quadratic formula, or if you are comfortable with completing the square, you can do that as well. For this one, you can opt any particular way. Now take out 27x out as common. The remaining is x minus 1, And from here, taking out 53 out as common, remaining is x minus 1 equals 0. And now we have two brackets, 27x minus 53 times x minus 1 equals 0. From here, x1 is equals to 1 and x2 is equals to 53 over 27. So these are the two values of x. Now substitute this to get the value of y, which is right here. So that will give me y1 as 4 minus 2 times x, 2 times 1 will give me 2. So x1 is 1 and y1 is 2. So y2 you'll get when I'll substitute x2 as 53 over 27. This will be 4 minus 106 over 27. And taking the LCM, which is 27 in this case, will give me 108 minus 106 over 27, that is 2 over 27, and that's the value of y2. And hence we have calculated two values of x and similarly two values of y. In this way you can solve any nonlinear simultaneous equations. So that's it for today, and in the next class, I told you in the next lecture, I'll explain you the whole complete graphical interpretation and the related questions. And also, if you are looking for live online classes for GCSEs for any subject, they are starting at just £6 per hour. And also, we provide classes for all years like KS1, KS2, KS3, A-levels. We have tutors for all subjects. And also, if you're looking for free worksheets, they are available on our website, and for free demo, just email us at exacademy@gmail.com. So that's it for today. Bye everyone. Take care.